Okay, cool. I think it's recording. Good morning, students. Happy Tuesday. Today we are going to be talking about comparing and ordering fractions, decimals, and percents. We're going to be looking at which one is greater than, which one is less than, which one is equal to. So the objective for the day, well, you'll be able to compare and order fractions by solving for their common denominator. And for our percents and decimals, we will be ordering them and comparing them by place value. So the vocab for today is LCD, the least common denominator. I'm sure a lot of you are familiar with it, but it will help us when we compare multiple fractions with different denominators, like this one right here. So when we're comparing fractions, we should follow some steps. You know, we have 5/8 and 7/12. Right away, we can think, oh, well, Mr. Henry, you know, we can just solve it, right? Well, how would we do that? If we simplify, we can't simplify 5/8. We can't simplify 7/12. So we might need to follow these steps. And the first step is to find the LCD of the two fractions, the least common denominator. And a method, you know, there's a few ways we can go about this. We can either multiply 8 times 12, 8 times 12, those are our two denominators, and when we multiply them, we will get 96. That is our least common denominator, and that's a big number, but this will always work. Another method is we can look for a pattern. We can look for a similar number. What factor can 8 and 12 both go into? And the smallest one is 24. So there's a couple of ways we can do this. We can find the pattern and just solve it that way, or we can do the multiplication where we multiply them by each other. And both ways work, and both ways give us equivalent ratios. So that's our first step, finding the LCD. Our second step we've kind of already done, write the equivalent fractions using the LCD. You know, using the LCD, we got these two fractions. Using the pattern, we got 15/24 and 14/24 fractions. And then step 3, we are comparing them. After all, that is what we are doing in today's lesson. We are comparing the numerators of the two new equations. And well, what we notice is 15 is greater than 14. And likewise, you know, same exact fraction, you know, saying it's equivalent. We see that 60 is greater than, it is more than 56. So there's two ways we can solve this, and I think whichever way is most convenient is best. So let's try these in our notebooks. Take a moment, pause the video. Remember to follow the steps and solve these problems. Welcome back after that short pause, or you just immediately know the question, the answers, and in that case, I commend you for that. So our first one, 2/3 and 4/9, we're going to find the LCD. Now, you can multiply 3 and 9 to get 27, or you can notice that 2/3 can be a factor of 9. You can see that 2/3, if we multiply the top and bottom by 3, we can get 6/9. And we're comparing that to 4/9. And well, 6/9 is greater than 4/9. So that's a solution we can have for that one. Our second one, we have 1/6 and 5/8. Well, once again, we can follow the steps and multiply the denominators to get the LCD, or we can see a pattern. And that pattern would be that 6 and 18 are factors. So we can do, you know, 1/6 times 3 times 3, and we'll get 3/18. And we're comparing that to 5/18. And well, we're comparing the numerators, and you know, 5 is greater than 3. So that is our answer for the second one. So either way that you solve it, you will get a correct answer. But what about the decimals and percents, you might be asking? Mr. Henry, you know, fractions, we know about the LCD, but what about decimals and percents? Well, actually, these are a little bit easier, I like to think. Especially when they are written in the same form. You know, when everything is written as a decimal, it is very easy to compare something. You know, if we want to compare 1/5 to, let's say, 2/10, you know, writing that out, 1/5 compared to 2/10, you know, we can certainly find the LCD, or we can just convert them into decimals. When you are comparing something, ask yourself, are these numbers written in the same form? And if so, can we transfer them into a new form? Can we take the fraction and write it into a decimal? Can we take the percentage and write it into a decimal? And the reason I like to write things as a decimal is because it's a good middle ground. Take this, for example, 85% of Lucita's free throws. She made 85% of her free throws. And Henry made 7/8 of his free throws. Who has a better average? Well, 7/8 and 85% are different. So I say we convert it into a decimal. With Lucita's 85%, well, 85% convert that into a decimal. Remember, if we move a decimal 2 spaces to the right for a percent, we're going to move 2 spaces to the left. And we'll get 0.85. That is Lucita. Now, Henry, on the other hand, he has, what, 7/8? 7/8, that doesn't solve very easily into a decimal, so we are going to have to divide. We are going to have to do 7 divided by 8, and, well, we will have to start solving. We'll have to add some zeros. We'll have to add some space so we can keep solving this problem. And I'm starting to be a little concerned because it looks like we might be getting a bit of a pattern. Oh, wait, nope, I screwed up somewhere. You're not getting a bit of a pattern. Mixed up the answer. There we go. So that is Henry's percent. And we got that by dividing. So once we took our percentage and changed it into a decimal, and once we took our fraction and changed it into a decimal, we're able to compare them a little bit easier. We have Lucita's 85%, you know, 0.85, and we have Henry's 78%, 0.875. And well, now that we have decimals, we're able to compare them straight away. We see that Lucita, you know, 85% is less than 87.5%. So our final answer is Henry got the best, what is it, free throw average? Yep. So Henry's average is greater than, because 7/8 is more than 85%. We know that because we solved that. Here are some others that we're just going to do some quick comparisons. We're comparing 1/3 to 33%. And we're comparing 11/25 to 4/9. So take some time, pause the video if you must, but let's solve it. And with 1/3, we're going to solve it by putting it into a decimal. 1/3, I remember that we talked about how we will have to divide it. And if you want to jump the gun, you might remember that it results in a repeating answer. And we're going to keep going. So 1/3, or I suppose I already wrote it right there. So 1/3 is equivalent to 0 the 3 repeating. So you know that 3 goes on and on and on. 33%, however, well, that's only equivalent to 0.33, 0.33. So our new ratios, 1/3 is 0.3 repeating, and 33% is 0.33. Well, you know, we would be, because of the way it's written, we're inclined to say that 33% is greater than. However, because that 3 is repeating, it goes on and on and on. So it's not a whole lot bigger, but it is greater than. So 1/3 is greater than 33%. Looking at 11/24 and 4/9, well, unfortunately, I think we will have to divide them, but I see a way that we can solve 11/25. We can multiply the bottom and the top by 4 to get it into base 100. So we have 100 on bottom, 44 on top, 44 over 100. Well, that is 44%, which is also 0.44. And since we're converting them into a decimal, we might as well do that. So there's that one. But with 4/9, well, we're not as lucky. We can't multiply it by 10 and get it to 100. So unfortunately, we will have to divide. So we're going to have to divide 4 by 9. We see that, well, we can do 0.4 times. That will be 3.6. And if you were present on Friday, we kind of talked about this. Whenever we have something divided by 9, we're gonna start noticing a pattern. We're gonna start noticing that it repeats. Much like 1/3, 4/9 is repeating. The only difference is it is a different value. So with 4/9, we get 0.4 repeat, 0.4 repeat. And that's our new fraction, or our new decimal, excuse me. So we have 0.44 for 11/25, because we multiplied by 4. And we have 0.4 repeating for 4/9. So again, we are comparing two numbers that are very similar, 44% compared to 44% repeating. Those two numbers look the same. However, because it's repeating, because it's going on and on and on forever, it is greater than. So keep that in mind when you're solving them. Just because they look similar doesn't mean they are. With these 3 examples, feel free to pause the video to solve them at your own leisure, but we're going to convert them into decimals, I'd say. Welcome back. 2/3 converting it into a decimal. Well, I remember that 2/3 repeats, and it will be 0.66 repeating. And well, six tenths as a decimal is just 6 tenths. And just comparing them right off the top, it's clear that 66% is repeating is greater than 6 tenths. With this one, we have a mixed number. So I think we're going to leave this guy as a decimal, and we're going to convert this guy into a whole number. And we're going to move the decimal place 2 spaces to the left. And we will get 6/5. 6/5 and 6/5, well, neither of those are greater than or equal or less than. So they're equal to each other. And then 7% and 7/10. Well, we can't compare percents and fractions. We need to put them in the same form. We're going to put them in decimal form. And the way we'll do that for 7% is we will move it 2 spaces. We'll include a 0. So it's 0.07. And for 7 tenths, well, we know that 7 divided by 10 is 0.70. So we have 7% compared to 70% essentially, and we know 70% is greater than. It has more value. The value is in the tens place, not hundreds place. So ordering with multiple numbers. So we, are able to compare numbers with each other. That's very good. But what about ordering now? The reason we convert to a decimal is because it's a very good middle ground. We're able to compare percents and fractions by making them into a decimal. And even if something is already in a shared form, such as these fractions, it might be a good idea to convert it into a decimal. And the reason is because when we're looking at this, we can compare denominators and, well, 2, 3, 4, 6, but they're already in order. And even looking at the numerators, we might also think that. We might need to reorganize for the numerators to be in order, but we might think that. So let's convert it into a decimal and then compare. We know that 1 over half is equal to 0.5. We know that 2 over 3, we just solved that one, is equal to 0.66, repeating. We know that 1 over 4 is equal to 0.25. See, already writing them in decimal form helps us solve quicker. And 5 over 6, well, we might not know that as quickly because that's not a common fraction that we use. So we actually will have to divide 5 by 6. And, well, the short answer of it is, let's find out. Because we're going to have to divide. And what do we have here? It seems like we are getting a pattern. I'm going to stop here. So we see that there is a pattern with 5 over 6. And the reason there's a pattern with 5 over 6 is very similar to the reason why there's a pattern with 2 over 3. I'm not going to say why that pattern works or what it is. I'll let you guys figure that out. But we converted all of our fractions into decimals, and that makes it a lot easier to compare. We know that 5 is less than 6. We know that 2 is less than 5. And we know that 8 is the greatest of everything listed. So the way we would rewrite our order, 1 over 4, 1 over 2, 2 over 3, and 5 over 6. So that is how we would rewrite our order. We took it from that and we had to change some of the answers. The way we did that is we converted them into a decimal. Very helpful. And we can do that with a real world example as well. For example, on our nutrition bars for any food, we have a label. And some labels say, for example, Nutri-Grains fruit and nut bar has 1/4 of its calories come from fat. That is found on the label. It says 1/4 from fat. Quaker Chewy Dips chocolate oat bar has 3/10 of its calories come from fat. And Cliff Bar, they claim they have 18.75% of their calories from fat. So we need to compare, what we want to compare, which snack bar contains the least amount of calories from fat. Maybe we're on a diet or maybe we're just trying to find a healthy alternative. So we want to find out which has the least amount of calories from fat and what order the nutrition bars should be in. So if you want to take a moment and solve, we've got 3 bars and we're going to be comparing them. I recommend we convert our information into a decimal so that we're able to easily solve and compare. Because we have 3 different forms right now. We have fraction, decimal, and percent. Like I said, I think that decimal is a wonderful middle ground. So now is a great time to pause and solve. Welcome back. For our first one, well, we kind of just did a quarter a second ago. We know that 1/4 is equal to 0.25. So that's that decimal. We know, hey, this is an easy conversion. We know that 3/10 is equal to 3/10. It is 0.3. And for this one, the Cliff Bar, we know that we move the decimal 2 spaces to the left. So we know that it is 0.1875. So we have our 3 new decimals. We have the Nutri-Grain. We have the Quaker Oats cracker, and we have the Cliff Bar. Fun fact, it only has 1 F in it. I don't know what's up with that. But yeah, so we have our 3 decimals, and we're comparing them now. And something you might be inclined to think is, say, Mr. Henry, this has 4 place values. Wouldn't that make it the largest? Not necessarily. When we're comparing place values, we always compare the value to the value. So because Cliff has 1 in its tenths value, and Nutri-Grain has 2 in its tenths value, and Quaker has 3 in its tenths value, I think we're going to put them in that order. So I think it's going to go something like this. And that is our order. We know that Cliff Bar, by the way, this was the chocolate Cliff Bar for anyone who's playing at home and is grocery shopping. We know that this is the Nutri-Grain bar. This was like a raspberry fruit thing. I don't know, it was the first thing that I Googled. And this was the Quaker Oats. By the way, this one is like the chocolate covered Quaker Oats bar, so it's not just the granola bar, it's like a chocolate one. But we can see that once we convert it into a decimal, it's much easier to compare which one of them has the least amount of calories from fats. And you can do that with all of your nutrition and such. The final one, some miscellaneous practice problems. I'm gonna let you guys take it from here. This is just some practice for you to do. This first one, coming up with 3 different fractions with different denominators that have an LCD of 24. Might I recommend, 2, 6, and 12. Those are some pretty easy ones. All of them can be written as over 24. The next one, we are just ordering them 2 over 3, 2 over 9, 5 over 6, and 11 over 18. What order do they go in? And then these 3, we're just saying greater than, less than, or equal to. Tonight's homework is on Buzz. It is to compare and order percents, fractions, and decimals. So be sure to do it. It is due tonight. But yeah, I'll leave it on this note. You guys can certainly work it in your notebooks, or if you are just so eager, you can start working on tonight's homework. But guys, thank you so much for sticking it out with me, and I wish you a whole lot of luck. I really should have a better send-off, so I don't know. Take it easy.